So you take your degree, you take your courses, calculus, linear algebra, algebra, and so on, and you hear about different textbooks, but usually it's the one that you've been assigned on the syllabus. What about the more classical ones in the field? How do you find out about that? Let's take a look. Departments with graduate programs in math usually have a comprehensive exam or a qualifying exam, and the syllabus of those exams usually has lists of textbooks in algebra, linear algebra, analysis, calculus, topology, and more. So it's worth it to go to those pages of those departments and look at the syllabuses and see what books they recommend. So I just picked two universities, the University of British Columbia in Canada and the University of Texas at Austin. So if you look at UBC's page, they have their qualifying exam syllabuses, and if you can take a look at the analysis one, you'll see that they have quite a long list in this case, starting with Alfor's complex analysis. Everybody knows that, and you'll see quite a few familiar names here, but the ones that stood out for me were the Introduction to Applied Mathematics by Greenspan and Benny, calculus, and Marsden's Elementary Classical Analysis. I didn't know about these books before, and they turned out to be really good, especially for the problem sets, because you'll notice, like, on these kinds of syllabuses, nobody is going to recommend something like Stewart's calculus, even though it's used in departments across North America and even in other places. They will usually stick to more classical books, and there's a reason for that. It's because of the kinds of problems that these books offer. Some problems that you just will not see in Stewart or books like that. Looking at the University of Texas at Austin, you can see their algebra page. They have books like Goldhaber for algebra and Kaplansky for fields and rings. Chances are you will not have heard of that, but you will have heard of Hungerford's algebra and perhaps Rotman's theory of groups. For analysis, one of the books that I learned about just by going through this stuff is Bruce Palka, that B. Palka, Introduction to Complex Function Theory. It's kind of like Gamelin and Alfor's crossed in the sense that it's more wordy, so it has a lot of detail. It is quite rigorous, but it starts gently and gets you into very advanced material, and it sort of takes the long way around in explaining things. So I really like that book, and I'm glad I found it. For the page in topology, you can see other references. In this case, they have Greenberg's lectures on algebraic topology and Massey algebraic topology from 1977, which is more of a classical treatment. But if you ask anybody, they'll probably tell you, look at Hatcher's algebraic topology. And for point set topology, look at Muncre's. But if you look at these syllabuses, you can find some extra references, and you'll be glad you found them because of alternative explanations and because of really good problem sets that give you the chance to really strengthen your background.